today we look at simplifying expressions with restrictions. So basically what we want to do is find out, like when we do a basic logarithm. So if we go back and refresh our brain on a logarithmic function and what its graph is, if we did this, if we had this basic logarithm, that was the same as saying 2, because my base is 2, my exponent is y is equal to x, right? So if we did a lovely table of values like we normally do, and because it's the y, my x is by itself, that's what I'm going to end up solving for. So I'm going to put values in for my y. And these pieces we've done, right? Like this is from the previous unit. So, and then I put that -2 in for y. This is going to work out to a 1/4. And I put a -1 in, and that's going to work out to a 1/2. And I put a 0 in, that's going to give me 1. And I put a 1 in, that's going to give me 2. And a 2, that's going to give me 4. So I go to plot all these points, and I'm going to have -1/4 and -2, and a 1/2, -1, and 0, and 2 and 1, and 4, 1, 2, 3, 4 and 2. Okay, so we get this graph that's looking like this. So when we look at this and we want to identify what the restrictions are, we start to look at your x. We got to determine what are our restrictions on x. So in this case, that we're kind of looking at and operating from the idea of your domain, right? Like what's your, sorry?
Oh, I sneezed, sorry.
Oh, it's all good, it's all good. So if I look at this and I say, I need to know what the restrictions are, I'm gonna say my restrictions, I'm basically that either x has to be greater than 0 in this instance, right? Because if we look at our graph, everything is larger than 0. It's all on the right-hand side of this your y-axis. So in this case, my restriction would be that x has to be greater than 0. So I could write it like that. This is a 0. Or I could write it in that, or other notation where we'd say that 0 to infinity, right? So that's basically what we're looking at, which makes sense because any logarithmic function, any log, x can never be a negative value, and it won't be 0. We'll never have the log of 0. So that makes sense for just a basic logarithmic function of what we've got going on, right? So in this case, our function, our restriction would be 0 to infinity on that piece. Now, if I looked at the next one, where I start to look at this, right? So now we're talking transformations to this. So now let's think about what's happening in this graph, but we're still all the while trying to figure out what are the restrictions on this. So if this was our base, we still have a base function of 2. So basically we're looking at the same original graph, but now let's talk about what's happening with this graph. Where is it going to show up? So, and more or less, what's going to affect our x values? Because that's the piece, right? Because it's about, does this graph shift left or right? Is it going to move that in that direction? Because if it's going to move left or right, that's what's going to affect our restrictions on that. So in this instance, what's happening here? Am I going to move left or right? And how do I know what I'm doing in this one? So let's go through. What does the 2 do?
Is it a stretch?
Yeah. So this is going to be a vertical stretch. So is that going to affect our domain at all? So that's all it's going to do is just go bloop. It's just going to stretch out that graph, right? But it's not affecting placement this way or this way, is it? Okay, what is the 3 going to do?
It's going to make it move to the left on the x-axis by
Okay,
3
so
units.
is it moving it left or right?
Oh, no, it's moving it right because
Yeah.
it's a positive.
So this is moving it right. So the moment I move right, that means everything is just going to get shifted over, right? So everything, so now basically my graph is going to come in however like that. So now what starts to happen then based on, now that's a poor example. I don't have it exactly drawn the way it is, should be. But the idea is I want you to see that from the one up here, we shift over 3 spots. That's what's happening here. So now what happens to your restriction, because then it doesn't matter, it's going to move up 1. It still moves up 1. It still doesn't affect, like this is my boundary right here, right? Like this right there is where it's going to end up, kind of that's the boundary, and anything to the left doesn't exist anymore, right? There's nothing over here. So everything is on to the right-hand side. So my restriction here would be what? Instead of it x being greater than 0, my x in this case has to be greater than, this is my piece, it's got to be greater than 3 now instead. So I could write it as x is greater than 3, or I can say that's 0, or no, yeah, that is totally wrong. Or I'm going to say 3 to infinity is my restriction on that. Okay, so now we start to look at some of these pieces. So the idea is this piece in here is the piece that starts to affect those restrictions for us moving forward. So what we need to start addressing then as we do this is to start to look at, we always look at our restrictions. Our restrictions always come from our domain. Okay, only because we cannot take the logarithm of a 0 or a negative number, okay? Which, when we look at our graph, okay, those x values, our very first graph that we looked at, our x values, we never had anything over here for our standard logarithm. We never have anything in the negative side of x, and we never had anything, x was never 0. It was always larger than 0. So that's why when we look at our restrictions can never be 0 or negative numbers. So that means when we look at a logarithm with a base of whatever value, in this case b, and c must always be greater than 0. So whatever value, whatever we have in there, that has to be greater than 0. If it's not, if it's less than or if it's equal to 0, then we've got an undefined situation because it doesn't exist, okay? So undefined in this case means that it doesn't exist. Okay, questions on that? Okay, so now what we're going to do, once we have the kind of the basic understanding of it, we're actually going to put this into practice, because looking at just a single logarithm sometimes, like what we just looked at, we look at these and we see, hey, we've just got one chunk of this that we worried about, and easy by just looking at it, we can take that little piece, that x minus 3, and from that we can identify, oh, well, really what we're doing with that, we were trying to figure out, well, the number, if I put a 3 in here, I would get a 0. So I have to make sure that I put values that are larger than 3 in here so that this doesn't zero out, right? So that's why when I come up with my restriction of 3 to infinity, I'm looking at, this is an open bracket because I can go right up to 3, but not including 3 in that, right? Like I could be saying 3.05 is not 3, but it's just a little bit bigger than that. So that's why I use that open bracket on here to indicate that I can use the 3, right? Because it's just meaning it's leading up to it. The ones we're going to look at now, these questions, we've got a logarithmic expression basically, right? But we've got all these tiny little logarithms in here that we have to account for. There's multiple restrictions that could pop up. We have to figure out what the true restriction, the overall restriction, because we might have restrictions on one piece of it, and then we have a different restriction on another piece of it. And we need to figure out, well, what's the one that actually will work, that will satisfy everything, right? So now what we have to do is we have to start to think about kind of, it says use the laws of logarithms to simplify the expressions. So in our process of simplifying, we also need to state the restrictions. So what we can do with this is we can start to look at, in order to find out our restrictions, we want to address each little piece on its own first, okay? And then we can worry about doing the simplifying. So let's figure out restrictions. These are, we're going to do first, and then we'll do the simplifying as the second piece of it, okay? So first is restrictions always. So when I look at my restrictions, I'm only looking at this piece right here, okay? So the piece that's after your log and your base value. So in this instance, I just have a lone x in here. So there's no transformations. I'm not adding anything. I'm not subtracting anything. I have nothing else contained in there. So this takes us back to our first example where we said, hey, as long as our logarithm, as long as x is greater than 0, then we're good to go. And since, look, I've got it as an x here, I've got it as an x here, and I've got it as an x here. All of these have the exact same term in it, right? So we're lucky in that instance. If they're all the same, you literally have one restriction and that's it. You have nothing else to worry about, okay? So this, in this case, because I don't need to go and write, oh, the restriction is x greater than 0, and oh, in this one, the restriction is x is greater than 0, and oh, this one is the same, so it's x is greater than 0. I'm writing it down once for all of them. So because it works for every single one of them. Does that make sense? Are there questions on that piece of that? Okay. So the next piece of this then is to take a look at this and basically try and figure out now what the heck is going on with the 4 log 3x minus 1/2 the log 3x plus 5 log 3x. So we need to now use what we learned from last day to simplify this into a single logarithm. So that's our task now, is to see if we can simplify this into a single logarithm. Any ideas of where we want to start first?
The bracket?
Okay, so what's happening in here?
It's subtracting, well, oh wait, no, would that be is that multiplication?
Yeah, you've got an addition in there, right?
Yeah.
So you've got a log 3 and you've got x. Okay, so you've got an x. Okay, what's happening here with the 5 log 3x? Do I need to write that differently first, maybe?
Yeah, it'd be log 3x plus, oh no, not plus 5. The 5 would be a exponent.
Yeah. Yeah. Okay. So yeah, I agree with that. So now once I've addressed that piece of it, now I think you're right. Now we're going to have to take, because we're adding these two logarithms together, we're going to multiply these two together, right? So if I go log 3 minus 1/2 times log 3, what's x times x to the power of 5? Treat the x like an x to the power of 1, right? So I'm multiplying same bases together. That means I'm going to add my exponent. So I really should have like that, right? 1 plus the 5 is going to give me the 6. Okay, now what? I think I forgot an X along here.
Do you multiply the half into the log? Is that?
Yeah, like this half is going to go where?
It's going to multiply into the 3. I could be wrong about that. I'm not for sure.
So think about the 5. When we had the 5, where did the 5 go?
It moved in with the it moved in as an exponent of the x.
You betcha. So this is no different. So this is a half in front of this log, right? So really this is a half. That half has got to go to that 6. So we're basically going to take that half and times it to that 6. Right?
As an exponent?
Yeah, it's still part of an exponent.
It's going to be very big.
Is it? What's a half times 6?
Oh, I thought it was going to go. It's just 3. I thought it was going in on top of the 6, so it'd be x 6 1/2 above it. But
oh no.
okay.
Yeah, no. So it's going to be 6. Well, because it's going to be 6 to the power of a half, but power to a power rule says we multiply, right? And then same thing while we're at it. This 4, where's it going?
It's gonna go into the with the 3 next to it.
As your exponent though, right?
Yeah.
Okay, so really I have this as log 3 x to the power of 4 minus I've got log 3 x to the power of 3 then, right?
Yes.
Okay, and now what's my last step?
Division?
Yes, absolutely. So that I'm going to go in this direction because I'm running out of room. So I should have log 3, and I'm going to have x to the power of 4 over x to the power of 3 then, right?
That looks okay. Are you allowed to simplify it even more by removing the x's since they're common with each other, or is that not okay?
No, you're right. So you've got 4 of them on top and you've got 3 of them on the bottom. So really you've got this as log 3 x, right? Like because 4 subtract 3, you're left with a single one still, right?
Yes.
Yep, definitely I want to see it that way. So basically with this is we identified what the restrictions were, and then after that we went through and we simplified. So the simplifying piece is the piece that you were working on and have been doing, right? So all today is just basically we're adding that restriction piece into this just to make sure we can make sense of that. Okay, so let's look at the next one, because the next one is a little bit different than what we're used to seeing, because now when we look at our log, we've got x squared minus 9, and in the other log, we have an x squared minus x minus 6. So in these instances now, our logs are a little bit more complex than what we are just with a basic x in these ones, right? So now what we have to do is we're going to end up with 2 different restrictions happening here. So now we got to kind of clean it up to figure out what is the overall restriction that we're working with when we go through this. So in order to do this, there's a couple things we're going to end up doing. So this subtract is going to do what for us? That's basically going to say we're going to divide. So we really, if we want to simplify this right now, what I end up getting is something that looks like that, right? it's just division right now. So I've basically taken my 2 logarithms because they were subtracting and I'm dividing them. Now, my next step here, in order for me to simplify these, this takes us to pre-calc 20 a little bit. It's going to come back at us, right? In the top, what I have going on here is what we call a difference of square. Remember when we factor difference of square, that really means I'm going to take the square root of the first term, and the square root of the last term, which is a 3. And one of these is going to be positive, one of these is going to be negative. Okay, so all I'm doing right now is simplifying this rational. I'm just trying to get the roots of it, trying to figure out what those roots are, because I need these. This is going to help me figure out where we move to next. And then on the bottom, you're factoring a trinomial. So I want to know now, because I'm going to basically break this into two brackets. I need to know two numbers that multiply out to a -6 and add up to a -1. So in that instance, I would be looking at -3 and a +2. So that means I'm going to get an x minus 3 and an x plus 2. Because if I take -3 times that 2, I get my -6. And when I take -3 plus the 2, I get the -1 that I want. So in essence to this, as I move through this, there's a couple things now that we have to address. So I need to figure out what my restrictions are. And in order to figure out my restrictions, I needed to figure out some values in here. So my factoring that I did in here actually helps us find our roots, those your x-intercepts per se, of each of these terms that we've got going on, because we've got to look at this as two separate entities here when we find our restrictions. So when we do this, we've got values of x is equal to 3, right? I'd have a root of x is equal to -3, and I'd have a root of x is equal to a -2. So those are going to become my 3 critical points moving forward. So this is like my number line. I'm going to plunk on my critical points on here on my number line, because now what I need to do is determine, hey, do I have restrictions? Am I good if I look at values like less than -3? Will this work? Will any values, if I put a -3 in, or a -4, -5, if I put those values in here, will it actually work? If I put a value between -2 and -3, will this section work? Right? So I'm trying to figure out which section along this number line, which values of x are going to work when I plug them back into my basic logarithm. So you're going to kind of create little test points. We're going to do a little bit of a sign analysis as we work through this, right? So we are going to do a sign analysis, and we need to use that x squared minus 9. And we also have to do a sign analysis on the x squared minus x minus 6. So what that means then is I am going to pick values. So I'm going to pick maybe a 4. I'm going to pick a value that fits in between each of these. So between -2 and 3, +3, I could pick a 0. I'm going to pick easier numbers if I can. Between the -2 and the -3, I might pick a -2.5. And between the -3 and on in this way, I'm just going to pick a -4 to make it work. You guys have questions so far? Like, you guys got to stop me if there's something that's, you're going, whoa, 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 why are you doing that?
I kind of got lost in the
Me too.
number line.
Okay. So basically, this is becoming my little glorified, like if I drew, right, kind of a coordinate plane. Because if you think about a logarithmic function, right, we're going to have these logarithmic functions that are going to graph, and we just need to know where are we allowed to be. Because here's the thing. We could have one graph. I could have a graph that's doing this, right? I could have another graph that is doing this. And I need to know, well, where my restrictions are. So this one only shows up on this side of my y-axis, right? But the other one doesn't. I need to find out where the line is, like where's the boundary where both of them exist. So in this case, I would still have restrictions I wouldn't be allowed anything over here because I just have the one graph coming in here, right? One graph is only showing up here. But then all of a sudden, by the time I get to this y-axis, I have both graphs starting to show. So technically my restrictions still hold true that it would be only in this section. So I would be going from where x is greater than 0 to get my restriction, okay? Even though in this logarithmic function that's coming in this way, I would have x values that would, negative x values over here that would satisfy it, but they wouldn't satisfy the other one. So that's what we're trying to do now in this question, is try to figure out, yeah, we're going to get it where they're going to be good in one section of this, but they may not be good in this section. So what we're trying to do is find out all the values that will work here and also work here. Okay.
And you need to test a point.
So that's why we need to test the points. So these values that I have here are essentially all the little kind of the critical values that show up. This -3, this -2, and this 3 are the values that I was able to pull from factoring. They are my roots, okay? So when I looked at the x plus the 3, the x plus the 3, when I set that equal to 0, that's the one that gave me the x minus 3. So that's where my -3 came from, was from this particular root, okay? Kind of like, you know, when we were doing those polynomial graphs. That's been a while, but when we did the polynomial graphs and you had to, right, find out all your x-intercepts, and it was always the opposite sign of what we see. So that's where we find the -3, -2, and a +3. I had to do that factoring to find them. And now what I'm going to do now, and then my numbers in red here, the 4, the 0, the -2.5, and the -4, I just literally picked a value that shows up, right? Like that belongs to that section in the number line, okay? That's arbitrary. I can pick whatever value as long as it fits between the value, right, in that section. So like between -2 and 3, I could have picked a 1, I could have picked a -1, right? Like I've got options in there. After +3, I could have picked 10. It doesn't matter what I pick, right? My objective now is to find out when I put these values in, these 4 that I picked now, I'm going to put them back into each of our chunks of our logarithm, and I want a positive value, because the whole goal here is we have to stay positive. So I'm looking for positives, but I'm looking for positives in both sections in order for it to be good for both sections of my logarithm. So if I take and put a 4 in for x squared, well, 4 squared is going to give me 16, and 16 minus 9 is giving me a +7. So right now, I'm getting a positive there for that piece, for the x squared minus 9 when I put a 4 in. If I put a 4 in for the x squared minus x minus 6, that's going to give me, well, 4 squared is 16, minus a 4, because I have a 4 in there. That would be 12, minus the 6, that's going to give me a +6. So this piece is positive as well. So this is what I'm looking for. I'm looking for to make sure that both become positive. If both of them are positive, then that means this section of the graph, that's part of my restriction. That's a good thing. That's where I'm going to see a positive values that are going to work in my logarithm. So then I go on and I've got to do each section like that, okay? So if I go over and I pick a 0, I put 0 in for x squared. Well, 0 minus 9, that's giving me a negative. The moment I got a negative, I'm done, okay? I need to have positives in both results. So the moment I get a negative, done. That means I have one section out of my logarithms that won't work. So that means I can't use that piece, okay? So then I'm going to come to the -2.5. And I put -2.5 and square that. Well, -2.5, so 2.5 negative squared is going to give me a +6.25, and then I'm going to subtract the 9. Well, that's going to give me a negative piece. So that one doesn't work. So I kind of saved myself some steps because the moment I get a negative, I don't even have to go to the other one, right? Because it doesn't matter anymore. It could come up with positive, but that still doesn't matter to me because I've got a negative value already. So now I go to the -4 side. I'm over here now. I put a -4 in for x squared. Put -4 in, that's going to give me a positive 16 again. So I'm going to get positive 16, subtract the 9. That gives me a positive. Okay, that's looking good. Now I better do the same thing on the bottom. So now on the bottom, I'm going to put a -4 in for x. And that's going to give me a positive 16. So that I'm good there. Minus, I've got a -4. So 16 minus a -4 is going to give me a 20. And then I minus a 6, which is going to give me a 14. So that one is looking good. That one's giving me a positive. So now I have another section. So I've got that section right here that also works for my restrictions. So now what I do, so now it's down to, hey, how do I write it? How do I write these restrictions to make them good? So I'm basically looking at from -infinity to -3, that chunk, right? Because I'm going back and I'm using these values, these special values that I had already picked, those roots, the critical numbers. So I'm acceptable on that chunk. And the other chunk was over here, which was from 3 to positive infinity. So those are my two. That's considered my restrictions right there. How does that feel? That felt lots for me.
It's a bit complicated, and I might need to look it over.
Yeah.
But
Yeah.
We can do another one like that. Yeah. So the other piece to this, so we found out the restriction. We just need to come back and we need to simplify the rest of this, right? So now you've got this log with a base of 2. Look at this x minus 3 and that x minus 3 from the top and the bottom, they cancel each other out. So you really have now, you're going to have log 2, and you're going to have an x plus a 3 divided by an x plus a 2. And now I snuck that in there and made that really tiny, tiny. But that's the idea. So we had to get it certain, like you could have honestly went through and simplified this side of it. But in order to do your restrictions, before you start canceling anything out, we need to know what all your roots are so that we could identify those values up here, right? So that's why I kind of stopped there, because we got sidetracked in doing this. You always need to make sure you figure out your restrictions before you do any canceling. Because if we canceled, we would have lost that positive 3 out of it, right? Like we had the x minus 3 divided by the x minus 3. Those, we would have canceled them out. And all we would have had for roots, if we looked at our simplified version, would have been the -3 and the -2. Well, then we wouldn't have gotten the other acceptable pieces that would have worked in this, right? So that's why it's really important that we find those values, our terms in here, before we do our simplifying. Okay, so why don't we do, okay, so if I look at the next one, A over here now, look at them. I've got a single x, I've got a single x, and I got a single x. So this one, your restriction again would be where x is greater than 0. So you would, since they're all virtually the same, they're a single term, that's where you can get a restriction. You're back to like we did in the very first one over here. So in that essence, you've got your restrictions, and then now you're just a matter of simplifying that after. So I'm not going to go through the simplifying process. But what I do want to do is let's do this next one over here, because this one's got, again, very similar to the one that we just finished, is we've got a little bit more elaborate pieces of logarithms here. Okay, so let's go through this process just like what we just did on the last one and see if maybe it makes maybe a little bit more sense. So first off, we are subtracting again, right? So if I do log 5, I'm going to have 2x minus 2 on the top. And I'm going to have the x squared plus the 2x minus 3 in the denominator, right? Because I'm dividing these, so, or I'm subtracting, so that means I'm dividing. Okay, any idea how we can factor the 2x minus 2? So if we think about this one, think about if you can take out a greatest common factor, GCF. So in this instance, can you take out a 2 and you're left with an x minus 1? And then on the bottom, we're back to doing that factoring a trinomial like what we did above, right? So same thing. We've got to look for two numbers that multiply out to a -3 and add up to a +2. So multiplies out to a -3, adds up to a +2. I think we're looking at a 3 and a -1, right? Because 3 times a -1 gives me the -3, and 3 plus a -1 is going to give me the +2. So the bottom I'm going to have is an x minus 1 and an x plus 3. Okay, so at this point I could go on and simplify, but right now I did it for the sole purpose right now to identify, I got to place numbers on my number line. Anybody want to take a guess of what are values that I'm going to put on this number line?
Would it be from -1 to +3?
Okay, you got your two values. Check your signs. So always think opposite of what's inside those brackets.
Oh. So in that case, would it be between -3 and then +1?
You betcha. Yeah, it's always the opposite of what's in there, right?
Yeah, I'm having trouble with that today.
It's okay. It's okay. Okay, so if I'm using that then, so I've got a -3 and I got a +1, so then I need to find, so I'm going to use test points of, well, something less than -3, so I could say -4. I need something between -3 and 1, a +1, so I could go back to 0. I don't know. I always like using 0 when I can because it makes it easier, right? And then on the other side of +1, I can go with a +2. So I need to, again, I've got that 2x minus 2. That's in my numerator. And I have that x squared plus 2x minus 3. That's what's in my denominator. So I have to test point this again, right? Like I've got to go through and figure out which one is where they're positive. And they both have to be positive in order for it to work. So does that seem okay? Kylie, how do you feel about that?
I'm just trying to process this all. Trying to write it all down.
Okay. Okay. Okay, so if I go and put a 2 in for this x, I'm going to get 2 times the 2, which is going to give me 4. And then I subtract the 2. So 4 subtract 2, that's going to give me a positive value. So that's a good thing. So that means I got to go down to the bottom one now, and I'm going to sub a 2 in for there and for all the x's. So that means I'm going to have 2 squared is 4 plus 2 times 2, which is another 4. So I'm going to have 4 plus 4, which is 8, minus the 3, which is going to be a positive 5. So that piece is looking good. Okay, I've got 2 positives there. So that means this whole section here, from the 1 all the way out, that's a good section so far for us, for the restriction. Now I'm going to go ahead and I'm going to do the 0. So I go back and put a 0 in for x this time. Well, 2 times 0 gives me 0, and I subtract 2. That's giving me a negative 2. So right there, that first one, that gives me a negative. Done. Okay, can't use that one. So now I'm going to go over to the negative 4. I put a negative 4 in for x. So 2 times the negative 4, that gives me a negative 8. Subtract the 2, that gives me a negative 10. That's a negative chunk. So right there again, I got a negative, I'm done. So in this case, I really only have one chunk here. My restriction here is going to be from 1 to positive infinity. So I can write it like that. Or I'm okay if you just write it as x is greater than 1. So you've got either way that allows for your restriction. So any of our graph, any values that we pick to put in for these logarithms have to always be greater than 1. Okay, not including 1, just greater than 1. So anything above. How does that feel?
Just copying it down.
Okay. And then we have to also consider, now we can simplify the rest of this logarithm, right? So when we look at the rest of this logarithm, I'm seeing that x minus 1 and that x minus 1, those cancel out. And I'm really left with log 5. I've got a 2 over an x plus 3. So that would be considered my simplified version. So the biggest thing here today is establishing those restrictions, right? So coming back, because the simplifying piece of it, you've done, although we're looking at some of these are a little bit more like complex with us having to factor. Did you guys have to factor any of them in your last assignment?
I don't believe so.
No?
Yeah, I don't remember factoring in the assignment.
Nothing. Okay. So that's a little bit of a refresher for us, right? Because we haven't done a whole, well, we did some factoring, the polynomial factoring a little bit, I guess, right? We touched base on that, but that's been a while. It feels like forever ago that we've done that. So that's kind of where you're at for today. That's all I kind of wanted to show you today. I think that's enough for today. That's kind of a concept in itself right there, right? So
Gonna need to study a little bit on it.
yeah.
Yeah.
Definitely need a refresher from 20.
Yeah, just for that factoring piece, hey?
Yeah.
Yeah.
I remember doing it, it's not really big in my brain.
Well, and like I said, it's been a while. Like we did do a little bit in that polynomials unit, but that was like the third outcome we did, and we were still back in school. So that's over 2 months ago, right? So it's been a while. Yeah. And any other factoring would have been done in your pre-calc 20. So that's even further away, right? So yeah. Yes, that's one piece, but those are pieces that come back, right? Those are pieces that are kind of important when you move forward. And even if you go into calculus, that's a piece that you would see again, right? So that's kind of, you never know when it comes back at you. Okay, do you guys have any other questions?
I think I'm good for now.
Yeah, I have enough things to try to figure out right now that I don't know what to ask for a question, so I'll look at it.
That's fair enough. Just please, you know where to find me. You text me if you have any troubles, okay?
Yeah.
Okay.
Have a good day.
All right. Well, you guys have yourself a wonderful weekend, and we'll see you on Tuesday.
Mm-hmm.
Yep.
Okay.
Yeah. See you Tuesday. Bye.
All right. Take care.
Thank you.
Bye.